Picture a cluster of servers with no manager and no master node. One of them, node A, has just learned a new fact the rest of the cluster still hasn't heard. Nobody is in charge of telling them. The fact itself is small, a new piece of state, say a configuration value bumped to version 7. Node A holds the fresh copy, while every other node still believes the older value is current. Where did the fact come from? A client wrote it, an update landed on node A and nowhere else. In many systems, there is no shared database to push it out. Each node must find out on its own. Meet the neighbors. Node B is just another peer in the same cluster, no more special than any other. In a moment, it will become one of the few nodes node A happens to talk to this round. Node C is another ordinary peer. The key idea is coming. No node ever contacts everyone. Each one keeps only a partial list of others, and each round reaches out to just a random handful like B and C. Behind them stand more nodes like node D that haven't heard anything yet. Picture rings of them rippling outward. The question is how a message starting at one node can climb through all these rings quickly. Node E sits out in that same outer ring. Multiply these unheard nodes into the thousands and the challenge sharpens. No central broadcaster, unreliable networks, and yet somehow every last node has to converge on the same fact. And nodes die. Here's the antagonist any real cluster must survive, a failed node that silently stops responding mid-round. Whatever spreads the news must also cope with peers vanishing without warning. Let's follow one update. It begins outside the cluster. A client writes the new value, and that write lands on node O alone. At this instant, exactly one node in the entire cluster knows the truth, everyone else is out of date. Node A now carries the update. Crucially, it does not try to phone every other server. Contacting thousands of peers directly would overload it and collapse the moment the network hiccuped. Instead, it does something almost lazy. Once every second or so, node A wakes up, picks a small random set of peers from its list, and sends them the news. Here the first pick is node B, which receives the fresh version 7. In the very same round, it also picks node C at random and shares the update. That is the entire outbound effort per node, a fixed handful of messages, no matter whether the cluster holds 10 servers or 10,000. Now the magic compounds. Node B, freshly informed, does not sit on the news. On its own next round, it behaves exactly like it did, picking random peers such as node D and passing the same update onward. Node C is doing the same in parallel, handing the update to node E. Every node that hears the news immediately becomes a new source for it, so the number of tellers grows at the same time as the number of hearers. Out at the edge, node D now infects node F, a node 2 rings away from where the update started. In just a few hops, the news has already leapt from one server to a spreading front of them. Notice node F also hears it from node E. The same fact arrives twice by different paths. That redundancy looks wasteful, yet it is exactly why a dropped packet or a broken link cannot stop the news from getting through. Step back and count. Each round, roughly, every informed node infects a few fresh ones, so the count of nodes that know keeps multiplying. This exponential curve reaches an entire cluster in a number of rounds that grows only with its logarithm. Gossip carries more than data. When node B picks the failed node for a round, its message gets no reply. One silence is not proof, so B simply notes the miss and lets other nodes weigh in before anyone concludes it is dead. That suspicion travels the very same way the update did. B mentions the missed node to D, D repeats it onward, and once enough independent peers report the same silence, the whole cluster agrees the failed node is gone, with no central monitor. Meanwhile, the update keeps flowing until there is no one left to inform. When every node holds version 7 and rounds stop changing anything, the cluster has converged. Give it a quiet moment and all copies agree that is eventual consistency. But what if two updates race? Each value carries a version, so when nodes gossip and find a disagreement, they keep the newer one and discard the stale. The exchange is a merge, not a blind overwrite, letting order emerge without a coordinator. A refinement worth knowing, nodes can gossip in 3 styles. Push sends what you have, pull asks what you're missing, push-pull does both at once. Periodically, two peers run a full push-pull reconciliation called anti-entropy, sweeping up whatever the quick rounds missed. Where does each node get its peer list? From Gossip 2. Membership itself spreads the same way, so nodes join and leave without any registry. Protocols like Swim even piggyback failure hints onto ordinary messages, so detection costs almost no extra traffic. Gossip is not free of downsides. It is eventually consistent, not instant, so for a brief window different nodes can hold different answers. And every message is somewhat redundant, spending extra bandwidth to buy that stubborn, coordinator-free resilience. It is a deliberate trade. This pattern runs real systems. Cassandra and DynamoDB spread membership and state by gossip. Consul and Surf use it to track health. Even blockchains flood transactions this way. Anywhere there is no boss and failure is normal, gossip keeps everyone roughly in sync. So the whole picture: one node learns a fact, then every round each node passes it to a few random peers. Hearers become tellers, the news spreads exponentially, failures are noticed the same way, and the cluster converges with no coordinator at all. One system demystified. Next time a cluster shrugs off a dead node or quietly agrees on a new value, picture the rumor spreading node to node, a few peers at a time. Simple, leaderless, unstoppable. Follow how it all runs for more. See you in the next one.